In the last lesson, we looked at how we named binary compounds. We learnt how to go from the formula, the chemical formula of a binary compound, such as NaCl, to its name, which is sodium chloride. We learnt that as we do so, the metal in the compound keeps its name, whereas in the non-metal, the suffix is changed to the "ide" form, so chlorine becomes chloride. In this lesson, we're going to see how we go from the chemical name of a compound to its formula. For example, potassium fluoride will become, well, potassium is the letter K here, and fluoride, well, that's fluorine, which is the letter F. So potassium fluoride becomes KF, whereas magnesium fluoride becomes, well, the symbol for magnesium is Mg, and then F2. So we're going to learn why there is a little 2 here, but there isn't a 2 here. And to understand this, we have to understand something called the valency of the element. That is to say, all of these elements in the periodic table have what is called a valency. Let's make a note of that. Now, valency is a rather old-fashioned term, and the modern term for the word valency is the oxidation number. So in order to write the chemical formula for a compound, we have to know the oxidation numbers of the elements in the compound. And this is quite easy to find. All we need to do is look at the periodic table. We will find that the group 1 elements all have an oxidation number of +1. The group 2 elements will have an oxidation number of +2. Group 3 will be +3. Group 4 +4. Now the group 5 elements will have an oxidation number of -3. The group 6 elements will have an oxidation number of -2. Group 7, that's the halogens, an oxidation number of -1, and group 8, that's the noble gases, an oxidation number of 0. So you'll notice that the non-metals have negative oxidation numbers, whereas the metals have positive oxidation numbers. Now you will understand exactly where these numbers come about when we talk about the electronic configuration of atoms, but we're not going to do that yet. All I want you to do is just remember their oxidation numbers. As long as you've got a periodic table sitting in front of you, you can quite easily establish that. So, what's the next step? Let's take a new substance called calcium bromide, for example. You need to find the formula for this. So the first thing you're going to do is you're going to look at the name, and you're going to see, well, we've got calcium here, which is Ca, and then we've got bromine here. Bromide comes from bromine, so we write down in the formula the symbols of the elements Ca and Br. Now then, we then take a pencil, and above each element we're going to write down the oxidation number. We look for calcium, here it is in group 2, so it has an oxidation number of +2. We look for bromine, here it is in group 7, so it has an oxidation number of -1. We then add those two numbers together, and what we want always is that these will come to 0, but we notice they don't. When you add +2 to -1, you get +1. So how can I make the sum of these two numbers 0? Well, I can do that by multiplying this -1 here by 2. So if I put a 2 down here next to the bromine, okay, that means 2 bromine atoms, so that's 2 times -1 plus 2 equals 0. And so now we have the correct formula for calcium bromide. Now once you've established the formula, what you do next is just rub out the pencil marks. Now I'm not going to do that, I'm going to leave those markings here for you. Now let's have a look at another substance, for example, sodium oxide. Okay, we follow exactly the same steps. We look at the elements in the compound. We see we've got sodium, and we know that that is, the symbol for sodium is Na. We've got oxide, well, we know that's oxygen, and the symbol for oxygen is O. And then we take our pencil, we write down the oxidation numbers. Well, sodium is in group 1, so that's +1. Oxygen is in group 6, so that's over here -2. We add those together and see that the sum doesn't come to 0. So we ask ourselves, well, how can we make that equal to 0? Well, so this time we're going to multiply the metal by 2, not the non-metal. So if I put a 2 here, I've got 2 sodium atoms, so that's going to be 2 times +1, which is +2, plus -2 will be equal to 0. So everything's in order when I place a little 2 down by the sodium. So I have 2 sodium atoms and 1 oxygen atom. Now then, let's just take one slightly more complicated example. Let's take aluminium oxide. Again, same procedure. The symbol for aluminium is Al. The symbol for oxygen is O. Get your pencil, look at the oxidation number. The oxidation number for aluminium is +3. The oxidation number for oxygen is -2. And we add those together and we can see that they don't come to 0. So how are we going to play this? Well, the way we do this is we multiply the oxygen by 3. There, we put a 3 there. That gives me 3 times -2 is -6. And then we multiply the aluminium by 2. So we get 2 times +3, which is +6, plus 3 times -2, which is -6, gives us 0. So everything's in order there. So what I'd like you to do now is click on the Check Understanding, go to the quiz beneath this video tutorial, and using this procedure determine the chemical formulas for the various compounds that are listed.